Okay, so today we're going to go ahead and talk about momentum. So momentum is just anything, I think of it as like mass in motion. So the equation for momentum is going to be, it's going to be a lowercase p, which stands for momentum, and it's just going to be mass times velocity. And again, p equals momentum, and m equals mass, and v equals velocity. Cool. So let's go ahead and think about what units we will use for momentum. So go ahead and take a guess in your head and then check back in. Okay, so we know the equation for momentum is P equals mv. Now we know that. Units of mass will oftentimes use our kilograms. Units of velocity are going to be meters per second. So units of momentum are going to be kilograms meters per second. Cool. One last thing, and I'll go ahead and write momentum is mass in motion. One last thing that I want you to think about is momentum a vector or scalar? Okay, so let's think about this. Okay, momentum is associated with velocity, and velocity has both a speed and direction. And we know vectors have both like a magnitude, which is a size, and a direction. And since momentum is associated with velocity, it is going to be a vector. So momentum is a vector. We're going to have to worry about directions and make sure when we're dealing with momentum in both like the x and y parts, we're going to have to split it up into the x and y components. Okay, so let's go ahead and solve two problems involving momentum. I would encourage you to read these problems yourself, try them yourself, and then check back on the video to see if you got them right or not. Okay, so let's look at the first one. So we have a baseball with a mass of 0.45, or 0.145, I can't talk, kilograms, is moving in what? The positive y direction with a speed of 1.3 meters per second. Okay, and we have a tennis ball with a mass of, what is that, 0.057, is moving in the negative y direction with a speed of 7.8 meters per second. Okay, what are the magnitude and direction of the total momentum of the system consisting of the two balls? Okay, so we know our equation for momentum is P equals mass times velocity. Since velocity is a scalar, again, momentum is a scalar, we're going to have to deal with directions. I'm going to say the upwards direction is positive, so we know the downwards direction is negative. Okay, so to find the total momentum of something, we are just going to add it all together. And again, we're only dealing with the y direction, so we can just add everything in the y direction. So it's going to be the momentum of the baseball plus momentum of the tennis ball. Cool. So let's look at this. Momentum is what? Mass times velocity plus mass times velocity. Okay, and again, I'm going to say upwards direction is positive. So it's going to be 0.145 times, what is that, 1.3, plus mass is 0.057 times the velocity is going downward 7.8, which that is the negative direction. So I need to make sure to have a negative 7.8 in there. Cool. I go ahead and I add that all together, and I get, being very careful with my signs, and I am getting momentum equals negative 0.256 kilograms meters per second. Awesome. Thanks for watching. Oh, cool. We have some more problems to do. We're not done yet. Okay, so let's look at the next one. So we have a 2.5 kilogram object, and it's dropped from a height of 1.4 meters above the floor. Okay, so we want the object's momentum after it's fallen 0.5 meters. So we want, I'm going to just go ahead and say it's fallen 0.5 meters, and we want the momentum right at that point. Cool. I'm going to go ahead and say upwards direction is positive. That sounds fun. We want to find the momentum. We know momentum is mass times velocity. And again, we're looking for it at 0.5. Okay, so mass is what? 2.5. Do we know the velocity at 0.5? No, it is moving. We do know that. So let's go ahead and find that velocity. So I'm going to go ahead and set up my this looks like it's falling through the air. This looks like a good old free fall problem. So I'm going to set up my VI, VF, A delta X delta T. So, and again, I would fill this out yourself and then check back in on the video. You'll learn more that way. So it's dropped. So initial velocity is 0. We want to find final velocity. Acceleration is negative 10 meters per second squared. It's in free fall. Okay, displacement. Am I going to use 0.5 or 1.4? Both numbers are in there. We only want the momentum after 0.5, so I'm going to just put in 0.5. And again, it is going downwards. That displacement is negative, so we need to do negative 0.5. Cool. So let's pick a constant acceleration equation. The one I'm going to use is VF squared equals VI squared plus 2A delta X. We can go ahead and plug everything in. Times what? 2, negative 10 times negative 0.5. Let's see. Put all that good stuff in. I do some simplifying at the end, and I'm going to get VF is going to be square root of something. It's going to be plus or minus 3.16 meters per second. Cool. But I do know it's going down, so I'm going to choose the negative sign, and I can use that to plug that back on in. So I'm going to just plug in negative 3.16. Cool. And I go ahead and get negative 7.9 kilogram meters per second. Okay, so now that we've talked a little bit about momentum, we're going to talk about change in momentum, which oftentimes we don't care about a quantity itself, we care about how much it changes. Change is so important in all of our lives. Okay, so go ahead and take a guess what the formula is for change in momentum and then check back in. Okay, so formula for change in momentum, we know change is always going to be our final whatever it is minus our initial. So change in momentum is going to be our final momentum minus our initial momentum. Cool, very nifty. So final momentum is going to be mvs minus initial momentum is going to be mvi. That is our good old equation for change of momentum. Cool. So I want you to think about how does an object change its momentum? And go ahead and write down any examples. Okay, so to change its momentum, it would need to either change its mass or change its velocity. It's a lot harder to change the mass of something and just like pull off the mass of something. It's easier to change the velocity of something without damaging it or totally changing an object. So to change the velocity, you would need to accelerate it. To accelerate something, we're going to have to apply a force. So to change a momentum, we will need to, a force is applied to an object. Cool. So let's go ahead and do one problem involving change in momentum. And always, I like writing down my givens because it helps me avoid silly mistakes or drawing a picture. So we have a 2 kilogram ball that is traveling to the right at 3 meters per second. The ball runs into a soft wall that causes it to stop. So here it is now, causes it to stop. I know the velocity is 0. So we want the ball's change in momentum. Cool. So I know change in momentum is mvf minus mvi. So in this case, our mass is 2. Our final velocity, so that's where it ended, is 0 minus 2 times our initial velocity, how it started, right? Let's say that direction is positive. So 3, so this is negative 2 times 3, or negative 6 kilogram meters per second. So that is going to be our change in momentum. So the object was slowing down overall. Cool, thanks for watching.